Okay, here is the page 6 for geometric sequence series about sigma notation and series. So this additional page is introduced because of the new syllabus, which finally says that it is necessary to know sigma notation in math applications. In math studies, it wasn't required, but oftentimes you would have to use sigma notation when you did your IA and you were talking about chi-squared. So it is handy to know sigma notation, and let's spend one page on it, okay? So what is the difference between a sequence and a series? A sequence is a bunch of terms added together, a bunch of terms not added together, and a series is a bunch of terms added together. Do you see that the U1, U2, U3, they're common in both? It's just that in a sequence they're separated by commas, and in a series they are separated by addition signs because you're going to add them together to form a sum. Okay? When you have S subscript n, the n is the number of terms that you're adding together. N is the general way of saying that, but usually you might have an n that is 100 terms, 20 terms, however many terms you're going to add together. You could actually put a number there. It doesn't have to be n. N is just the general case. So you can see that if you are going to do S subscript n, that corresponds to adding up all the terms from the first term to the nth term. The Greek letter sigma, which is the Greek S, okay, so sum, sigma, is often used to represent a sum of values. So the notation is like this. Basically, what you do is you say big sigma, and then you put the index, which you're very familiar with after having done the arithmetic and geometric sequence and series units, and then you just put the first and the last number for that a series here. So like for example, if you're going to add the numbers from the terms from the first term to the 10th term, you would write it like that. Okay, even though we often use n for the index in our units for arithmetic and geometric sequence series, sometimes we also like to use n for the maximum value, so we put n here, so then we're forced to use something else for I. Usually we use I, J, or K, okay? I being the most popular because it stands for index, right? What do you put inside here? Basically what you put inside here is the general term. If you remember when you do arithmetic sequences, the general term is un equals u1 plus n minus 1 over d. So since we're using I instead of d, you would put u1 plus I minus 1 times d. Okay? And in the case of the geometric sequence, you would put u1 r to the n minus 1 for u subscript n. Now, if we were going to do u subscript I, in the case of using sigma notation, we would put u1 r to the I minus 1. Okay? So that's how you fill in the general term. We're always going to be doing, in the cases of the exam, we're always going to be doing arithmetic and geometric sequences, so you just fill it in with the general term like that. Okay? Alright, now let's look at some specific examples here. So here it says, for example, for the sequence 2, 4, 6, 8, 10, S1 equals 2, S2 equals 2 plus 4, S3 equals 2 plus 4 plus 6, S4 equals 2 plus 4 plus 6 plus 8, and so on. So we could write it also with sigma notation, where again we put I for the index variable, and then we put the index variable here too, and then we put the first index term here, first index here, and the last index here, because we're going to add the first through the fourth term, the first through the fourth term. Okay? How did they get this 2i? The easiest way to get the 2i is to look at the sequence, which is a geometric or an arithmetic sequence, and say, okay, what is the general term for these? Well, to find the general term, I need to know U1 and I need to know D. So U1 in this case is 2. D is plus 2 plus 2 plus 2, so it's 2 also. If I wanted to write the general term, I would write UN equals U1 plus N minus 1 times D. So that would be equal to 2 plus N minus 1 times 2. Now, if I wanted to simplify that, I would put 2 plus 2n minus 2. 2 and minus 2 cancel out, so you end up with 2n, which in the case of the variable I would be 2i, and there you go. You see? So you don't need to sit there guessing it. You could just use the techniques that we learned up until now, which is to write a general term formula using this formula sheet formula, plugging in the U1 and the D that you can see obviously by looking at the sequence, and then it gives you simplified 2n or 2i. Okay, so don't like bang your head on it. Just say, oh, it's an arithmetic sequence? Well, I'm going to do what I always do. I'm going to use U1 plus N minus 1 times D. Geometric sequence, I'm always going to use U1 times R to the N minus 1. Okay? All right. Let's go look at number 11. Consider the arithmetic sequence 1 plus 3 plus 5 plus 7 plus blah, blah, blah. Find the number of terms in this series. Okay, so this part of it is very similar to problems that we just did in the arithmetic sequence unit. Okay? All right, so first thing we're going to do is we got 1 plus 3 plus 5 plus 7 plus, and a whole bunch of numbers, we don't know how many, plus 61. Let's figure out what is the general term formula first, okay? So the general term formula is going to be what we copy from the formula sheet, which is UN equals U1 plus N minus 1 times D. Okay. And in our case, we can see that U1 is clearly 1, and it looks like D would be 2 because all these numbers are separated by 2. So basically, let's fill in what we know. So UN is equal to 1 plus N minus 1 times 2. Okay? And we know that the nth term is 61, so we could set 61 equal to 1 plus N minus 1 times 2, so we can figure out what N is. Subtract 1 from both sides, we get 60 equals N minus 1 times 2. Divide by 2 from both sides, we get 30 equals N minus 1. So N is equal to 31. So this is the 31st term. Okay? So the answer to this is 31. Write the series using sigma notation. Okay, so remember with sigma notation, we basically have sigma I equals the first term to the last term, which is 31 in this case, and then we put the general term here, which will be 1 plus N minus 1 times 2, except for instead of N, we're going to use I, so it would be 1 plus I minus 1 times 2. 1 plus I minus 1 times 2. Okay, if you want to simplify it, go ahead, you can. You can multiply 2 times I, you can multiply 2 times negative 1, and you could simplify it, but I'm fine with this, okay? So that is the series using sigma notation. Find the value of S. Okay, so this is an arithmetic sequence. We know that the arithmetic sequence has U1 of 1, and we know that it has a D of 2, and we know that the N value is 31. So how do we figure out what the sum is? We use, come on, erase. Okay, so the sum of the first 31 terms is equal to, remember, we could find the formulas from the formula sheet, which are N divided by 2 times U1 plus U31. Okay? And so U1 we know is 1. U31 we know is 61. And N we know is 31. So if we put 1 plus 61 in the calculator, that would give us 62. 62 divided by 2 is 31. 31 times 31 is It would be 961. So the sum of this sequence is 961. Last problem here. Consider the sum sigma I equals 3 to, I think this is supposed to be n. Okay. Or x, I'm sorry. It's x. Where x is a positive integer greater than 3. Okay, so write down the first three terms of the series. Okay, so if we write down the first three terms of the series, the most easiest thing to do is just plug in the indexes for the first three terms. Normally we always have I equals 1 down here, but this one is I equals 3, which means the first three indexes we're going to use are 3, 4, and 5, right? Because we're always going to just increment by 1 every time. So the first term is U3, and the way we find it, we do 3 times 3 plus 1. We just plug in 3 in for I, and that gives us 9 plus 1, which is 10. What about U4? U4 is equal to 3 times 4 plus 1, which is equal to 12 plus 1, which is 13. U5 is equal to 3 times 5 plus 1, which is 15 plus 1, which is 16. So our sequence is 10, 13, 16. Okay, so that was that one. Then it says write down the number of terms in the series. Well, we know that the last term is x, but we don't know what number is x. They want us to say, oh, so there's x terms. Well, if I equals 1 was the first term, then there would be exactly x terms. Since it starts with I equals 3 instead of I equals 1, it has 2 less terms, right, than 1 through x. If it was 1 through x, that would be x terms. If it's 3 through x, that would be x minus 2 terms. Given that the sum is 520, find the value of x. Okay, so now we're finally going to figure out what x is going to be. So what we know is that 520 equals the summation I equals 3 to x of 3i plus 1. And I am going to rewrite this as an arithmetic sequence which starts from 10 and jumps by 3. And so if I do that, instead of I equals 3 to x, I'm going to put I equals 1. And then instead of 3i plus 1, I'm going to put u1 equals 10, d equals 3. I'm going to put 10 plus I minus 1 times 3 instead. And if I write it like this, then that means that I can put, instead of x at the top, I'm going to put how many terms there are, which is x minus 2. So I'm going to put x minus 2 on top. Now what I can do is I can use the sum formula for arithmetic sequences to figure out what this expression looks like. And it's going to look like this. The sum formula says that n over 2 times u1 plus the last term, which is un. Or, in this case, we don't have un, so what I'm going to put instead is 2u1 plus n minus 1 times d. Now I'm going to rewrite it using u1 equals 10 and d equals 3. If I do that, it'll be n over 2 times u1, which would be 20, plus n minus 1 times 3. Okay. Now if I rewrite this part that is highlighted, then I would write 520 equals n over 2 times 20 plus n minus 1 times 3. If I wanted to solve for n, I would just expand everything out, and then eventually I'm going to get a quadratic, as you might see. 520 equals n times 2 times 20 is equal to 10n. This would become 3n minus 3, right? And if I multiply that times n over 2, I would get 3/2 n minus, I'm sorry, 3/2 n squared minus 3/2 n. Okay? And then I'm going to subtract 520 from both sides so that I get 0 on one side so that I can actually solve the quadratic. Here I have 10n minus 3/2 n, and that gives me 10 minus 1.5, which would be 8.5 n plus 3/2 n squared minus 520. And then I'm just going to change the order a little bit. I'm going to put 3/2 n squared first. 3/2 is just 1.5, so I'm going to put 1.5, 8.5 n minus 520. And now I'm going to highlight that, and I'm going to put this into poly-SMLT and solve it. So poly-SMLT order 2, because it's a quadratic, and I'm going to put these coefficients 1.5, 8.5, and negative 520 in for the three coefficients, and I'm going to press solve. And it gives me, there are two solutions, negative 21.6666 or 16, and can only be a integer, a positive integer, so we put 16. So the answer is going to be n equals 16 initially, but in this case, even though n is equal to 16, our n is x minus 2, right? So we set x minus 2 equal to n, so x minus 2, equals n, which is 16, so x is equal to 18, because if I add 2 to both sides, 16 becomes 18. So the x value is 18 in this case, that s equals 520. Okay?